It's also my second conference in Ukraine where I'm presenting. And I've noticed, and probably I also scared some people off because of the English speech. What I like about Ukrainian conferences, which is kind of specific to, I'm not sure if it's about this country, but in general, is that basically I can also attend it and enjoy the presentations, because all the presentations are typically delivered in Russian or Ukrainian, but they are subtitled, right? So all the decks are in English, so I can, like watch some movie with the subtitles. All right, so what I'm doing in Microsoft, because I believe I don't need to introduce the company, I actually work with customers and partners, helping them do something with data, right? So I'm covering a lot of different technologies. We will talk about some of them during this talk. I'm not data scientist per se. I don't have PhD. And actually I'm enjoying this sort of broader perspective. The biggest thing about data science for me is actually the way it impacts the business. So this business flavor is something that I enjoy the most. All right, we will be talking about large-scale cognitive APIs. So what that basically means. We will be talking about two personas, let's say. So most likely, if you are just thinking about data science nowadays, you are probably around this right-hand side of this picture, right? So you can imagine yourself or somebody else working in this field as as a scientist, right? So coming with with this nice white coat. But I still remember the times where data scientists were not called data scientists; they were rather talking about data miners, right? And this is basically the guy over there. So quite often, when you look at the evolution of these roles and how the market evolves, you may notice that there is a little bit of the traction between those two guys, right? Which means basically that if you would try to assess the mood or sentiment or emotions of those two people, you might find something like that, right? So those newcomers are really happy, right? This is really cool, a lot of new stuff to learn, to practice, etc. On the other hand, there are practitioners with some experience, right? So those are the guys that are doing data for, let's say, 10 or 15 or 20 years already. They are sort of neutral at most, maybe a little bit sad or tired. And I kind of understand it, right? Because this is something that we are not talking about during the conferences, but quite often this is really cumbersome, right? Which means that, well, you would love to do a lot of cool things, a lot of cool models, but most likely you will spend a lot of time, and I mean a lot of time, digging into data, right? And cleaning it and finding out all the proper resources. And this is really tough, right? So that's not really impressive. This is far away from the pure science, but that's the reality. So just a word of warning. All right, so let's move on and talk about the topic of this speech. So I'm not sure how many of you know this particular website or have heard about it, howold.net. Quite a few of you, right? This is actually a 2-year-old website. If you don't know it, this is basically the beginning of our cognitive services. I mean, commercial availability of cognitive services. So it was really stupid website, right? You can just, and it's still available, by the way. You can go there, just upload your picture or connect your webcam, whatever, and we'll try to assess your age and gender as well, you can see, right? So nothing really spectacular. But 2 years ago, when we presented it during the conference, this question popped up quite immediately, right? So can you handle your success? We are hearing a lot about a lot of startup companies in Ukraine, right? You are trying to, to conquer the world, to build your presence in some foreign markets. But are you really able to handle your success? And I'm talking about pure technical capabilities, not really business ones, right? So what that meant for us, right? This really plain site with just, a small pop-up generated such traffic, right? So this is basically when we announced during the conference the availability of the cognitive services, and also we've exposed the website to the public, right? I am not presenting all the details, but you can look at some of the stories in media, how basically market reacted, right? So you can see that, within a couple of days, we've reached more than 1 million visitors per hour, right? And those visitors generated 7 million images per hour. Quite a lot, right, if you think about it. That's something that we couldn't actually expect. So to process this data, we needed to handle or to be prepared, and we've consumed more than 1,600 cores, more than 5 terabytes of RAM, and you can see that at peak we've been processing more than 2,000 pictures per second. So quite an impressive number, right? It's all because of viral marketing, right? It wasn't us. It was basically the social media that generated that traffic. So that's another warning for you. Be ready and think about how to basically scale your business in the proper way. What this meant for us, during the first few days, we've seen a collapse of the website a couple of times. And it wasn't because of the model or the API. It was because of the website that was just hosted on some single virtual machine or whatever. Basically, the blog or the website engine couldn't handle the traffic. Fortunately, the API that was running underneath was perfect when it comes to scaling it out. So that's basically how you should also think about your models that you are trying to build, right? One thing that you usually do not consider, at least not very often, is not just model accuracy, but also how it will perform on a large scale. And one of the answers to that is, for example, using some sort of APIs, be it others or somebody else's. So, talking about Microsoft offerings and what I'm doing here, and what we will be talking about when it comes to cognitive services, it's not just about APIs, obviously. We are doing a lot of stuff related to machine learning or artificial intelligence. What does it mean to be precise? Well, obviously we are working a lot with personal assistants or agents. We do have Cortana that we've investing recently quite a lot. Most of our application, our product lines, are somehow exposed to data science. And actually, if you will have time, I'll show you in a minute how, for example, we are integrating machine learning inside Office suite, right? So some of Office products have machine learning built inside, and that's kind of hidden from the consumers, but it's definitely there. We've also had a lot of services that are delivered out of the box that you as an analyst or data scientist can reuse. And obviously we've got infrastructure to either build your models from scratch or use some pre-canned models that somebody else has created. So if we would try to somehow look at the breadth of offering that we can provide is actually quite complex. So you can start with just renting some hardware infrastructure. And that's definitely important for anybody in this room that is dealing with, for example, deep learning. Deep learning is obviously the hottest topic in the industry nowadays. Everybody's talking about it because we are able to significantly shrink the amount of time that is needed for the model computation. So here we are providing, let's say, GPU farms for your needs. On top of that, there are some platform services that basically do not require a lot of administrative skills to make use of them. Having an ownership of Bing or Outlook.com or, I don't know, Xbox obviously gives us a lot of freedom when it comes to data processing. So we internally are able to gather a lot of telemetry and make use of it. We are also providing some algorithms. Some of them are commercially available. Some of them are delivered for free as an open source. One of the open source projects that I can recommend for you to look at is called CNTK, or Cognitive Toolkit. This is basically deep learning framework that we are providing, both on Linux and Windows. And there are obviously a lot of work related to, let's say, commercial packages like Microsoft R or SQL Server or Azure Machine Learning, etc. And on top of that, there is cognitive services and bot framework. And we'll be talking briefly about cognitive service, I would say, right now. So what cognitive services APIs are? Quite often, if you think about data science and you are just at the beginning of this journey, you have several choices, right? You can, for example, try to hire some data scientists. And that's extremely tough. If you think about current market, everybody is fighting for data scientist resources, right? Those people are extremely expensive, at least comparing to the rest of the IT industry, and also very rare, or relatively rare. I'm not sure about Ukrainian market, but in general, that's definitely the truth. So you can basically follow this path, but even if you find somebody, it's quite complicated to, for example, onboard those people and to keep them busy, right? Because they might be quite picky. So if you present them with some basic stuff, they might not like it so much, right? They are scientists, right? So they can easily move to some other company. Or even if you find somebody that is skilled, it's quite hard if you, for example, have a couple of different areas or projects or scenarios that you need to manage. So let's say you are doing some business that touches both image processing and natural language processing. It's, I would say, almost impossible to find people skilled in those both areas at the same time, right? This market is deeply specialized. So without having an experience with language processing, cognitive sciences, it's hard to basically switch between one and another. So one of the approaches that we've done is cognitive services APIs. What does it mean? Well, that's actually quite easy. Think of it like that. We are Microsoft, right? We have like 120,000 people all over the world. Probably more than 10,000 data scientists inside already. And we are building a lot of models, right? We've done it for a couple of years already. Think of Skype, think of Bing, all those big global properties. Why simply we would not expose those models to the public, right? And obviously try to sell it, right, if possible. So that's kind of usual being a commercial company. And that's actually what cognitive services are. So if you think about the whole data platform that we provide, it's just a tiny bit of it, right? But it's extremely crucial for somebody who actually starts thinking about what is the business purpose, what is the business scenario. So that's the place for the cognitive services. And what is the benefit of them, right? So those are pre-configured, pre-built models that are coming out of the box, that are very easy to use. They are exposed through REST APIs, so basically de facto standard in the industry. They are quite flexible, not as flexible as, let's say, your own model, obviously, but can give you at least some starting point and help you, fix certain immediate or urgent needs that you have. They are also well tested because they are coming from our own business. So, we've done it already. And they are pretty much open, so you can see that you can use it from virtually any technology on the market. All right, so just very quickly going through all those offerings, because right now, cognitive services, that's roughly 30 different APIs that cover different groups and different purposes. You can think of, for example, image processing or vision processing. You can, for example, look at face API or emotion API. You've seen those pictures at the beginning of the presentation. That's basically the outcome of those APIs. There are also some video APIs that if you're doing, for example, video streaming might be quite useful. We've just, for example, provided an API called Video Indexer that automatically transcribes the video and tries to recognize objects in the video stream, making the description, textual description. There are also some APIs covering speech, so be it text-to-speech or speech-to-text. language, natural language processing. So if you're doing, for example, text analysis, or you try to create your own chatbot, you can also use, for example, the service called Language Understanding Intelligence Service. That's basically the way to integrate your application with your end users that will try to communicate with your app using natural language. There are also a lot of different other APIs, like, for example, recommendations. So we've seen during the keynote the story about Netflix. You don't need to be Netflix and invest $1 million to basically tune your model. You can simply take it as it is. So in most of the cases, if you're having like an e-commerce business, you don't really need to spend a lot of time tuning your model. You can simply start right away using such API. There are also search APIs coming from Bing, as you can see. And the last one is something that we've announced quite recently, a month ago, called Microsoft Cognitive Services Labs. And that's basically all the new stuff that is coming out. But that's something that is working, and this is also kind of my legacy. I used to work a lot with software communities. Now, when I moved to data science, it's a little bit different, because I've noticed that you usually do not see a lot of live presentations, live demos. It's mostly slides. So if you'd like to impress the audience, you just shoot some mathematical formulas on the screen, and everybody says wow, and you just follow up. I don't like it really. I still prefer to do it in a legacy mode. So let me do some quick demo. All right, so what I'm trying to do, and obviously one of the beauties of live demos is that everything can crash, but hopefully it's not the case now. Let's just explore. Yeah, you can see it as well. Let's connect to my cam. All right. So a lot of things can go wrong. You can see, wow, I'm so young. It's thanks to the lightning, so I'm really happy. What you can't see here, but probably we can show it. There are quite a lot of information here. So first of all, I've been recognized as a person. Thanks God. It's indoor. It's man. Cool. And also some description, some natural language description of this picture, right? So, and unfortunately, I'm not a celebrity. So sorry for that. So that's one of the cases when you can, for example, imagine using such APIs. I can obviously in the break present quite a lot of cool other demos, but as we don't have a lot of time, let's go on. So that's one part, right? Let's say you found some really cool API that you'd like to consume. What can you do about it? The biggest challenge, talking about scalability, is how to actually use those APIs together with your data, right? APIs are quite, basic animals. You just take the picture, send it through the internet, something will process it and send back the result. But if you have, let's say, a couple of million of those images, as we did, it becomes quite challenging. How can you actually move the data between the internet and your model and your customers or consumers? So how can you solve this issue? There are a couple of things you may do, and that's basically generic, not really related to our Microsoft Cognitive Services, but in general. So let's imagine you have some sort of machine learning model built already. You'd like to somehow apply it on top of large amount of data. What can you do? Well, I won't cover SQL Server 2017, even though in most of the cases, when I'm talking to customers, they are not really facing big data yet, right? So if you are talking about a couple hundreds of gigabytes of data, you can quite easily just embed the model inside SQL Server. I'm not sure if you're aware, but from the version 2016, we are enabling an ability to embed the models inside the database. Which means basically that you can put any Python or R code inside the database and make it running as part of the database, which is quite cool. Another thing is obviously use some sort of distributed approach. So the most famous one is Spark or Hadoop or whatever. So I won't focus on that. The last thing that I'd like to cover, and that's also because of it's rarely unknown service, and I'd like to focus the rest of the pitch on this particular one. So data lake analytics, what is it? For those of you how many of you are working with Hadoop already, by the way? All right, still not that many. So for those of you who are not yet working with Hadoop, you can imagine that this is like a Hadoop for, well, I shouldn't call dummies, but maybe for the newcomers, right? So if you're willing to do some sort of big data stuff, but for some reason you are scared of, learning for half a year, both, administrative stuff and then how to develop on top of Hadoop, you can just start with data lake analytics. The whole idea is basically the same. So what basically we provide? Well, we provide, for those of you who are using Hadoop already, we provide Hadoop clusters, right? You can just take them as they are. But for those of you who, for example, are not using Hadoop or Java and prefer, for example, Microsoft technologies like .NET, you can go with this nice combo. What this means, basically, there are two separate services, one to keep the data inside, the other one to process it. So you can start really quickly. The marketing slide says that you can start within 30 seconds, and I kind of agree. So what you just need to go to Azure portal. If you forget about it, you just look at your neck. I can see that Microsoft Azure is here. So you just go to the portal, register, create a service, and that's basically it. You don't need to wait for the cluster to be created for you, as you usually do with Hadoop. You don't need to think about infrastructure. You are just focusing on the processing job, right? So let's say I'd like to process, a few terabytes of data. The data is already there. How can I do it? I just submit the job, and that's it. And what I pay for? I just pay for the job, for the query, for nothing else, right? So the quicker the query takes, the more relatively I pay, but obviously the result is faster, right? So that's basically the whole idea. Similar to Hadoop, but different even from the pricing perspective. So there are two components, as I said. One is called Data Lake Store, the place where you can store a lot of data. And by a lot, I mean unlimited amount. This is something that we promise. And this is not just suited for big data, it's also ready for any other purposes, right? The good thing about it is this is basically HDFS store. So you can connect any Hadoop cluster as part of it. And this is something that we've proven. Cloudera already supports it. Hortonworks is about to support it or is supporting it already. So that's basically like a standard way to communicate with your cluster. It also provides data encryption, role-based security, etc., etc. So from the enterprise businesses, it's really important. And then there is data lake analytics. So this is this analytical engine that can run on top of your data. So how it usually works? You have some data, be it on premises or already in some cloud. It can be large database, maybe data warehouse. It can be some clickstream data, or maybe some unstructured log files or whatever. Then you apply certain processing, and then move it to the final store, let's say. So it can be relational database, your data mart, or some even dashboard, or be it Excel file, right? To do this sort of processing, we actually created a new language, It's called USQL. So it's pretty much SQL that you already know, I hope. Even though you're data scientist, you should know SQL if you don't know it already. But it also provides an extension point. And this extension can be either done in Python, R, or C#, right? So I think it's quite kind of cool. So those are the basics. We don't have a lot of time to cover that, but you can see that this is pretty much a usual SQL stuff. Nothing really special, besides the fact that in this particular example, we are not using any sort of relational tables. You are just registering certain, in this case, files. So that you can see that there is text file that I'm connecting to and trying to apply certain schema, right? And there is no table as it is. So we've created an orders object that will have this sort of attributes, and then you can select or join, merge them, whatever you like. And then after those sort of transformations, we are sending the output to, in this case, another file. So this is basically what is the basic idea behind the processing of this data. What is also cool, you can also communicate with external data sources. So let's say you really have some relational database beside, and you'd like to merge the data coming from database together with your log files. No big deal. You can just connect to a different source and run the query within the database. So the whole processing will be done close to the data, as always. So let's imagine going back to the main topic of this talk. How can you scale out your model, right? So first thing, you need to think about API or the way to expose the model. But if you'd like to also run this model on top of large amount of data, you can simply throw all the, in this case, images, let's say, into a data lake store and then apply this sort of processing using either data lake analytics or SQL database, all two of them all together. So you can obviously support not just single files, but quite complex file structures. So in this case, you can see that we've got partitioned data using multiple directories. And this is basically an example how easily it is to communicate with those APIs that I've already presented. So there are built-in integrations with those, for example, image recognitions API. So in this case, I'm just referencing the assemblies called image something, right? And then apply them on top of all those images that I've collected. So just to move forward, as we don't have a lot of time, what this code is doing, and by the way, you will find it in the conference materials, obviously. We are taking the raw images, applying in parallel different processing pipes. First, we'll basically try to identify objects on each of those pictures, and then some emotions, if there were some people on that. Then filter out all the relevant data, join those two row sets, and then by aggregating them, we can obviously do some filtering, some averaging, whatever. Send the results back to some, in this case, file. So this is the outcome. You can see, file location, what is the mood or emotion, some pre-selected tag, gender, and age. So you can see how easy it is to basically apply this sort of API on top of your data. In this case, we are not moving any data, right? There is no internet connection required. It all happens within the same data center. So this is basically the outcome. You can present some nice dashboard out of it. How it scales out? Well, quite simply. I was talking about data lake analytics being a competitor to Hadoop, and that's kind of true. The only thing that you need to define is the level of parallelism. So how much resources you'd like to apply on top of your query, on top of your script. And by applying this parallelism, you are actually engaging different number of what is called AU, so analytical units. And you can see this benchmark has been done on top of roughly, I think, 800,000 images, so let's say almost 1 million. And you can see that we are able to go from something like 22 hours to 2 hours just by increasing the number of parallel jobs, right? So this single slider that you are selecting while submitting the job can basically save a lot of time for you. All right, we don't have, unfortunately, time for demo, at least not this time. But I'd like to, first of all, talk also about SQL Server. I also already mentioned that there is Python and R built into it. You can obviously play with an open source approach. So let's take Spark, for example. We do provide Spark, for example, integration with deep learning frameworks. So that's also coming out of the box if you'd like to have, the usual stuff. So Spark together with, let's say, Café or here, we can provide it as well. And if you are really technically savvy and willing to, or are already doing a lot of deep learning stuff and are thinking how to scale out your efforts, we've just announced private preview of something that is called Azure Batch AI training, which means basically that we will be providing a deep neural network infrastructure. So a lot of GPUs for your usage. We are already announcing that it will support a lot of, or most common DNN frameworks like TensorFlow, CNTK obviously, and Trainer. So if you are interested, just go to our site, register, and hopefully you will have access to this nice stuff. Okay, so just to finish up, as I said, I was rather talking about how to make your models work in the proper way, not really how to create your models, because I'm sure that you already know how to do it. There is no need to fight back between your data engineers or developers and your data scientist team. It should be one single, let's say, team or body. And to make it even more compelling, we are now working on something that is called Team Data Science Lifecycle. And this is actually a topic in itself, so I won't cover it at all. You can actually read about it. There is a GitHub page covering the process and as a sort of a framework, structured framework to deal with the data science inside your own organization. And obviously, let's stay in contact, right? So quite a lot of reading here. This is the contact to me. And I still have a couple of minutes left. So before we start with questions, I'd like to show you with these nice, I think, cool things when it comes to how to turn your data science into some consumer world. And, for example, integrate it with Office, as I said. So how many of you are aware of data science or machine learning models inside Office? Can you imagine any scenario or any product?
Tooltips?
That's kind of easy. It doesn't require machine learning. At least I hope so. These are static. So let's even imagine the tool that I'm using now. So what is it? PowerPoint, right? Can you imagine a scenario for PowerPoint and data science or machine learning? All right, so let me show you something.
Coloring images. PowerPoint.
Coloring images. So you have black and white images and you'd like to color them. That's kind of tricky. It's not there yet. Sorry. Is it still working? Yeah, at least I'm still connected. All right. So, yeah?
I have a scenario.
Yeah, what kind of?
We can film the audience during presentations, then analyze the faces, the emotions, and align to the slides what slides attracts more attention of audience and someone like this.
That's really cool. That's not part of the product. This is something that we are doing in some of our offices, by the way. We are using Kinect cameras to basically analyze audience when it comes to customer areas. So it's not part of PowerPoint, but I can imagine it happening. Actually, I used to use a very similar pitch roughly 2 years ago when I was talking to the audience, and I basically said that all the chairs are connected, so we are tracking basically, the customers by some sensors.
The most easiest one, auto-completion in Excel. If you type some numbers, it just predicts what it should be.
We will go with Excel in a minute, but let's just finish with PowerPoint, all right? So let's just, for example, select some picture. What happens in the newest release of PowerPoint? And by the way, this is PowerPoint 2016, which means that we are updating, the product every month. So you better keep an eye on all the changes here. So let's try to find some nice picture. All right, I think this one might be interesting. All right, and what happens now? If you look here, there is a new feature called Design Ideas. So out of this picture that I've just presented, I can select the template, right, or create the template. So let's say I like this one. Here it comes, right? So this is actually based, this is supervised learning, right? So we first of all collected a lot of ideas coming from the professional designers, but also we are improving the model, right? So it's part of the product, kind of hidden, unfortunately. Talking about Excel, this should impress all the people that are working with the real data, right? Everybody uses Excel, right? So we are talking about autocomplete. Imagine the following scenario. We've got full name, first name, last name. And then how would we split this data into these fields? Usually. By applying some formulas, right? So equals something. And I hate formulas because I never remember all of them, right? So there should be some easiest way. This is autofill, or actually this is called flash fill, right? So imagine I've never done anything, right? It's like, fully automatic. The system analyzed all the data. I didn't need to select a single column here. So just by analyzing what is present right now, I can create, all the required work without a single formula here. So just to show that I'm not, faking anything, let's just. Cool. So that's not all. Obviously, that's kind of maybe easy because we are working with names or whatever. So maybe we are using some basic heuristics here. But imagine a different scenario. Let's say we are having some sensitive data, right? For example, credit card information. We'd like to hide some parts of this information. So these are, let's say, credit card numbers. You can see that they have different lengths, right? And I'd like to somehow hide the middle one. This is the most sensitive part. What I'm doing now. This is an example, right? Here it comes, right? So it doesn't really matter what I'm providing. It's just what we call it learning by example, right? There are some cases, obviously, where a single example will not be enough. But if you provide 2 or 3 of them, then most likely you will see those patterns appearing, and then the system will learn by itself. So that's, I think, quite cool feature also for the data scientists as well.